Hi everyone, thanks for watching this fifth tutorial of the Optocomb Suite by Kutia. Today we are going to use the Optocomb Scaler toolbox in order to calculate the volume of combustion chambers and automate the inspection process of a cylinder head. The combustion chamber that we are going to investigate today has been scanned with the L90 Optocomb scanner by Kutia. If we visualize data with Optocomb Viewer, we can see that the quality of the 3D data is pretty good. And thanks to the coaxial measurement configuration of the Optocomb sensor, the combustion chambers have been fully profiled down to the valve guide. Okay, so now that we have taken a look at the 3D data, let's jump to the Scaler toolbox. So let's click here. Okay, here we are going to calculate the volume of each combustion chamber of the cylinder head. To that end, let's load a calculation recipe that I've already prepared. We then press the play button and the calculation starts. The algorithm first extracts the top surface of the cylinder head. It then detects the surface of the valve seat for all 4 combustion chambers. Once the valve seat is known, the algorithm can calculate the volume of each combustion chambers. So running the software with a very simple laptop, the full calculation took about 10 seconds. And it outputs the volume of each combustion chamber. All chambers are about 29 cube centimeters, but based on the high accuracy of the Optocomb 3D scanner, the algorithm has been able to calculate very small variations of volume from one chamber to the other. As you can see, providing that you have the inspection recipe ready, the process is very straightforward. So now, I would like to walk you through the making of such a recipe. So let's move to the recipe window. It shows the reference dataset we just used. So let's create a new recipe and save it under a new name. For example, new recipe. Okay. First, we want to set the lower limit for the cylinder head's top surface in the measurement coordinates. So here is going to be about 8.3 millimeters. Now, when you scan multiple parts in a row, there are always slight differences in the position of the part with respect to the scan area. So we need to define 2 balls that will be automatically detected by the algorithm and will serve as reference points. We will choose 2 spark plugs as reference balls, but we need to define in roughly what area the reference plug will be. So let's choose the first area around the upper spark plug. And the second area around the lower spark plug. Now, we need to input some information regarding the design of the cylinder head in order to help the algorithm detect the surface of the valve seat and calculate the combustion chamber. Let's start with the exact position of the reference spark plugs. I create 2 sets of XY coordinates for the plugs. The upper plug first, and the lower plug. Let's now input the position of the 4 combustion chambers. So I create 4 sets of data for the 4 combustion chambers, and I input the XYZ coordinate of their centers. I also need to add the radius of the chamber, 36 millimeters. Now for the second chamber. Same for the third one. The XY coordinate. And the last chamber. The radius. Okay. We then input the position of the input and output ports with respect to the center of the combustion chamber. We then input the radius of the valve seat for each port, the angle of the valve seat surface, as well as the angle of each port's axis. So I create 4 sets of data for the 2 output and input ports, and I fill in the XYZ coordinates and the angle of the port's axis, the radius of the valve seat, the angle of the valve seat. Wait, let's correct that. Okay. We now switch to the second port. The radius of the valve seat, the angle of the valve seat, the third port, radius, angle, and the last one. XYZ coordinates. I just want to quickly check for any input error. Okay. Okay, here we go. Finally, we need to do the same thing for the spark plug and input its radius as well as its position with respect to the center of the combustion chamber. Radius, okay. And we're almost done. In the last section, there are additional data processing and calculation parameters that we can fill in, but we can mostly leave the default values. The only parameter I would like to modify here are the lower and upper limits of the cylinder top surface. And that's it. We save the recipe and we are ready to run it in order to inspect the cylinder head. Here we go again. And complete. And you see that this second recipe is very similar to the first one, and it outputs in about 10 seconds the same inspection data for the volume of combustion chambers. This was pretty simple, and once your recipe is set, you are actually ready to inspect 100% of your manufactured parts on the shop floor. As we showed in tutorial 3, the scanning software works seamlessly with the analysis software, so in this case Optocomb Scaler. And as a result, the overall inspection process can be fully automated from measurement to data processing, data analysis, and part assessment. On that note, I thank you for watching this video, and I encourage you to learn more about 3D metrology and Quality 4.0 at kutia.global.